Okay, here's some sample problems using GM. And we've done this one before. We just simply say, okay, what is the geometric mean between 6 and 8? Well, it is the positive square root of the product of 6 and 8, which is the square root of 48, which is 6.93. What is the geometric mean between 2 square roots of 2 and 3 square roots of 2? Well, it's the square root of 2 times the square root of 2 times 3 times the square root of 2. Ooh, seems like a mess. Let's just look at that. We can take the 2 and the 3 and multiply them together and get 6. We can take what's under the square roots, multiply them together, and we get the square root of 4. Okay, so let's work what's underneath the square root. That's 6 times, what's the square root of 4? It's 2, so 6 times 2 is the square root of that. So that is the square root of 12, which is 3.46. Okay? Sample there. Now let's take it over and put it into one of those right triangles and use it for Theorem 8.2, or the right triangle GM theorem number 1. Geometric mean theorem number 1. We have a right triangle. We have an altitude from the right angle to the hypotenuse. It breaks the hypotenuse into 2 segments, 2 and 6. Now, what Theorem 8.2 says is, oh wow, that altitude, the measurement of this altitude is the geometric mean of the 2 segments, the length of the 2 segments that is created by that altitude. Well, the length of those 2 segments is 2 and 6. So what's the geometric mean of 2 and 6? That means that x simply equals the square root of 2 times 6, or the square root of 12, which is 3.46. Okay? Another example. I have another right triangle. Dropped an altitude from the right angle. That altitude divides the hypotenuse into 2 segments. Now, we're showing actually on the figure that this whole part is 16 and this piece is 12. Well, how big is this piece? Simple subtraction says that that piece is 4 long. Okay, the length of that is 4. So these 2 segments are 4 and 12. So what's the length of x? The length of x is the geometric mean of 4 and 12. Well, that means it is the positive square root of 4 times 12. 4 times 12 is 48, so that means it's a positive square root of 48, which is 6.93. Okay, some simple samples of how to use geometric mean to get geometric mean of just 2 numbers, and then how to calculate the length of an altitude given the length of the segments that are created. Okay, now we're going to do a couple of more complex problems dealing with those symmetric and those similar, not symmetric, but similar triangles that are created by this altitude. Okay, now we're going to do some samples in using the similar triangles that we've got. We've got a triangle here, a right triangle. We've dropped an altitude from the right angle to the hypotenuse, creating 3 similar triangles. And we've got some unknowns here that create some relationships. They actually create ratios that create some proportions that we can solve. And in order to simplify what these relationships look like and how these similarities look, I've devised this little table that will help us figure out what's going on. And we've got the columns represent the triangles. First column, S triangle, is a small triangle. The second column is M triangle, or medium triangle. And the last column is the L triangle, or the large triangle. So what we're talking about is this small triangle over here, the medium triangle, and then the whole triangle. Then the rows represent the different sides of the triangle. The first row represents SL, or the short leg. What is the short leg? Okay. Second row is the long leg, or LL, the long leg. And the last one, of course, is the hypotenuse, HYP. So what we're going to do is we're going to put these numbers in here, and we're going to then look and see how we can solve and find x and y. So let's look at the small triangle and let's look at the short leg. The short leg of the small triangle is 3. So what does that leave the long leg to be? The long leg is x. Just put it there. We'll worry about what that means in a little bit. And when we look at the hypotenuse of the small triangle, we notice that it is y. Oh well, that doesn't look too promising right now. But let's go on to the medium. The medium, or the middle triangle, let's look at the short leg, and it's x. Oh well, we got more unknowns than we got knowns. How are we going to solve this? And now what's the long leg of the medium triangle? And it is 8. Okay, something's coming out. Now what's the hypotenuse? We don't know. There's nothing marked there. There's not a variable. There's not a number. So we're just going to leave that blank. We must not need it. Now let's look at the large triangle. What's the short leg? The short leg is y. What's the long leg? We don't know. It's blank. Have no idea. Now, what is the hypotenuse? Add this whole thing together. We get 8 plus 3 is 11. Now, let's look and see what we got here and see if we can put something together. Now, remember we talked about ratios? Okay, chapter 7. Notice this ratio right here. We can mark it. What do we got? 3 is to x equals x is to 8. Wow. Cross multiply and let's find a solution. Cross multiply. X squared equals 3 times 8. How are we going to find that? We don't want x squared, we want x. So we take the square root of both sides. So x is going to equal what? Oh wow, we could have figured that out. Why? Because the altitude is a geometric mean of the two segments created by that. So we could have done that. But this points it out and shows us what that relationship is. Okay? So x equals square root of 24, which is, oh, I can't do math very well. We're going to try to figure this out. Square root of 24 is 4.9. Okay? All right. That's that one. Now let's go on and let's try to see if we can find y. If you notice for y, what we've got here is we've actually got this little proportion right here. It's in black. What do we got? 3 is to y as y is to 11. So 3 is to y equals y is to 11. So take the y's. Y squared equals 3 times 11. Okay? We really don't want y squared. We just want y, so we're going to take the square root of 3 times 11. Oh, wow. Y is the geometric mean of this number and this hypotenuse. Okay? What is that? Y equals square root of 33, which is 5.74. Okay? So that's what we're talking about and how to solve some fairly simple problems. Okay, using a table that will allow us to relate this. Now, could we have done it another way? Sure. We can find the geometric mean of this thing to find x, because that's the definition of the altitude of this situation. Then, knowing this number, could we use Pythagorean theorem to get that hypotenuse? Sure. This squared plus this squared equals this squared. Take the square root of that and you've got it. So there are other ways of finding this. This just happens to be a simple one. When the problems begin to get more complex, it works a little better. Let's do some more complex problems.